Hello, everyone. Today we will continue our introduction on firewalls in the first quarter of this lecture, and later we will move on to security protocols in networks. That's an important part of network security. So let's head for the remaining part of firewalls. So we have mentioned, as you see for this, the sidebar or for the slides, we have introduced two types of firewalls. The first type, which is rather basic but very efficient, that's a packet filtering firewalls. These type of firewalls filter out some of the incoming or outgoing traffic based on the source IP address, source port number, destination IP address, destination port number, and protocol numbers. These are five essential elements in the rules of the file tables. And last week we learned that some of these packet filtering firewalls are not good enough to have a fine-grained policy on some type of traffic, especially when we set the firewall default policy of the firewalls as reject or drop. In this case, it's more convenient to use stateful packet inspection in addition to the basic file tables to provide more fine-grained file filtering. So as you see in the slide here, this stateful packet inspection, basically it keeps tracks of the status, the states of some related packets. If originally one packet, IP packet is allowed for some type of connection establishment, then all subsequent related packet will be allowed. But if there are others packet or traffic coming to the firewall, but they are not relevant to this established connection, then this type of IP packets wouldn't be allowed. So they will be dropped. That's the essential idea of having extra stateful packet information. Now let's look at another two types of firewalls. The first one is called Application-Proxy Firewall. Also, it's called Application Level Gateway. In fact, from the proxy, this term, you may guess out that this type of firewall acts as a relay of application level traffic. The idea is the firewall will interpret the content of the application. This is so-called the application data in IP packet. And based on some rules, they will decide whether to forward this IP packet, this application data to the destination or not. And also they might manipulate on the application data and also manipulate on the application, the IP addresses, the source and destination IP address of the application data. That's the idea of application proxy. And in this sense, let me switch to my iPad screen. So in this sense, we have Application-Proxy Firewall. So suppose we have a client. I'll simply write C as a client, and we have a server. So if there's no firewall in between, now we have some request from the client, and then the server will respond to the, so we see like response, or we can see reply from the server to the client. This application could be like a web application using HTTP protocol. It could be a Skype connection to the client wants to send to the client to the server with some video chat, and also it could be an email application that the client send out some message to the server, ask the server to further relay this email. And when we talk about application proxy firewalls, it works like this. I will copy it to save some time. In this case, we have this firewall. It's application proxy firewall. So when the client sends out this request, and in fact, the firewall acts as a role of the server. I write in blue. And the server will investigate the application data. Sometimes it even change some of the content of the application data. And then it will forward the application data to the server. Let's see, it's request prime. Here it's a request, original request. And here it's client. Here this request prime, it could be exactly the same as a request, or it could be slightly different from the request. It depends on the configuration of the firewall and the policy that is previously built in the firewall. And then the server reply is request. And again, the firewall acts as a client to receive this reply from the server. It will look at the application data, could change some of the content, and it will forward the reply to the client. So in this process, you see if the content of the application data has been significantly changed by the firewall, the user will notice that. But sometimes if the data is only changed at this very minor part, or it's rather the change is rather subtle, then the end users may not notice this revision in this process. And this type of configuration in application proxy firewall is specific to different applications, because each application, they use different protocol, then the format of the application data will be quite different. And in this process, you have seen that the firewall has extra capability to look into the content of the data, even modify the data. So in some sense, it's more secure than simple packet filtering. It could be more secure than stateful inspection firewalls as well. But it has a significant processing overhead on each of these connection, because previously it's just like the communication is from the client to the server and the server back to the client. But now with this middleman in between of them, then you see the communication overhead is quite significant. So this is the application proxy firewall. And since these application proxy firewalls are quite specific to each application, sometimes that's not necessary, although it provides extra security protection regarding certain applications. And the community proposed another type of proxy for firewall purpose, which is called circuit level gateway. In this case, they basically set the firewall at a lower layer. As you see here, for previously, it set the firewall at application layer. And for the circuit proxy firewall, they set the firewall at the transport layer. So it means it will be transparent to applications, to the end users. So the general idea is quite similar as application and proxy firewall. So it sets up two TCP connections between the client to the firewall and between the firewall to the original server. And then it relays TCP segments from one connection to the other without examining the contents of the application. But in this case, they can manipulate some information at the transport layer, like manipulate the sequence number of the application data. You can consider this manipulation as like two separate TCP segments. And there's a lot of fields that can be manipulated by the firewall in the header information. So the security functions here in this case it is to determine what kind of connections will be allowed by the extra manipulation on the TCP headers. And because it's independent of the applications at the upper layer, so it's normally used when the inside users are trusted. And so these two types of application proxy firewalls, the application level gateway normally is set as the inbound from the outside, the external network, and the circuit level gateway is mostly set as the outbound traffic. So then you have this the combination or hybrid of these two firewalls. Excuse me, I need to talk to a student who visits me. Just I thought you will come to me in the morning. It's up. Yeah. Yeah. Okay. Thanks. So let's continue. That's basically the general idea of this application-proxy firewall and circuit-proxy firewall. It's quite a high level. Do you have any question regarding these two firewalls? It's quite high level, so I think you can understand it quite properly. And now then we can move on to file lecture, a file architecture. It's basically where should we place a firewall in the network. There are two types of locations for the firewall in the network architecture in an enterprise. As in the beginning of the firewalls, I mentioned like you can have firewall at local computers where like each computer with the operating system can set up a firewall. But if in a larger enterprise with thousands of computers in their network, it's not necessary to set a same rule in multiple computers at the same time. So it's more convenient and efficient to set the firewall in the network, especially in the gateway. And here we have these two possible architecture of setting firewalls in the network. The general idea is to divide the network of an enterprise into two parts. One is public-facing servers, like a university or an enterprise. They mostly maintain a website or email server, and also a domain service. These are the services of the organization that is designed to face the public. And there are also other type of services within the organization, like the HR system or the financial system of the university or of an organization. These type of services within the enterprise and organization is not supposed to be accessed by the external network, or at least all external requests should be well controlled when they want to come into enter into the network of the enterprise. So that's the idea. Here, first, let's look at this one-layer file protection. That's about where we should set the firewall. And suppose you see at the right hand, we have this internal network of an enterprise. And there are computers and servers in this network. And if we only set one firewall, it's quite natural to set the firewall right behind the gateway router, like here, behind this gateway router, or sometimes it's directly these two could be built in a same device. And in a larger enterprise, sometimes they have two layers of firewall. One is for the public-facing part of the network, as we have seen in the previous slide. that the mail server or the web server, DNS server, these services are supposed to be accessed by the public, and but still they want to control only certain type of incoming traffic can access these services. It's not like these servers are open to all kind of requests. So in this case, they have this firewall set up to allow some traffic that to request some services from these servers. This part is called this demilitarized zone, because it's relatively more public to more open to the public. And then we have this more sensitive internal network that needs better protection, better control of the network traffic. And after this, they set another layer of firewall, which has more strict rules, pretty much like, for example, it only allows the computers in the internal network to visit certain web pages, not all the web pages, not all the websites. It's like if you consider this internal network as a student lab in the department, then it's quite natural to set the rule that like Facebook, Twitter, this social media, or other irrelevant website should be blocked by the firewall here. Then the computers in the lab will only have access to some websites that are related to student study, not something else. I think I might need to mute you all. If you want to talk, then you can. If you want to talk relevant to the lecture, then you can unmute yourself. This is the idea of setting two-layer firewall protection in an enterprise network. So that's a kind of come to the end of the firewall part of our lecture. And here I give this summarizing key points. So basically, firewall controls traffic into and out of a network, and it can control based on the services, direction, user, and the behavior. Regarding user and the behavior, the application-proxy firewall has the capability to control some of this user or behavior of the IP packet. And packet filtering, that's very basic. We already recapped it in the beginning. And stateful packet inspection, that's in addition to packet filtering firewall tables, it maintains extra state information database. And the last one are the proxy firewalls we just introduced to relay application or application traffic, or to relay TCP connection traffic between the client and the server. So remember that proxy firewalls play two types of roles, both the client and the server in the context of the traffic. Okay, I think that's pretty much what I need to say about the firewalls today. Do you have some question regarding the firewalls? I didn't see you have